Hello and welcome back to the Aimless Electron. I know it's been a while, but I've been pretty busy. In that time though, I've come up with some great ideas for the next videos to come. I promise not to make it take so long to get those out to you guys either. In this video, I'm going to continue on with a series about the large format LED screens based on the ws2812bs. This time I decided I wanted to have something more mobile, so I started with the idea of having it first be wireless, and I wanted it also to be controllable from something like a tablet. So I made it just a Windows 8.1 tablet running a regular .NET application. I also used an FPGA to drive it this time instead of a microcontroller like the last time where we used an ws2812b. Anyways, I'll describe all of that on the whiteboard, so stick with me and let's go check it out. Here's the high-level overview of the hardware. We'll go into more detail of the hardware when we look at that next. To start with, I used a Windows 8.1 tablet PC running some custom software I wrote in C#. It just captured a small part of the screen, sent that data out over TCP to an ESP8266. The ESP8266 was housed on its own ESP12 board, which in itself was sitting on this dev board I got from NodeMCU. This made it really easy to program and use because you just plugged it into USB and uploaded your code. The NodeMCU has a small USB to serial chip on it, so that ran really easily. The code that I uploaded to the ESP basically took data from the TCP connection and streamed it out as fast as it could over SPI. That SPI connection was to an FPGA, which actually drove the screens. The other connection we have here was a ready signal. When the FPGA was ready for the next frame, it would pulse this ready signal, which in turn would be sent to the software running on the tablet, saying, hey, give me the next frame. The FPGA I used was the Mach X02. It was also sitting on its own dev board, which made things really easy. Plug it in, had its own power, ready to go, you could push your design to it. Next I used SRAM as a frame buffer. That was a 16-bit by 64K SRAM. That means we had a 16-bit address bus, a 16-bit data bus, and then I had an output enable and a write enable line, and that was it. Finally, we had 48 lines of data going out to the 48 rows of pixels that we had in our screen. Those were divided up into 8 signals each, which were sent through a 74HC245. This is just a buffer, and that we also used it as a level shifter, so we could translate the 3.3 volts to 5 volts. This also was nice because if something happened over here, we weren't going to short out and fry the FPGA. So let's take a look at the hardware now. Alright, here we have the actual hardware itself. If you notice, it's in this plastic box. This was really convenient so we could just put the lid on it and hot glue anything that was popping out the edges. That way no dust got in it and no drinks could be spilled on it and short everything out. It also has the ESD bags at the bottom as its own little anti-static mat, and those were grounded. You may also notice that there's breadboards in here instead of a custom PCB. That's all because we ran out of time. So these breadboards are just hot glued down, and then the wires are hot glued into the breadboards. It was like $3 or $4 each for the breadboards, and just a couple bucks for the wires, so it wasn't any big sacrifice. Now let's talk about the hardware itself. You may notice that this board wasn't on the whiteboard diagram. Well, that's a little power adapter board, and it has this, I think, M-size barrel connector, so you can connect a wall wart or a power brick like this directly to it. Power button, this indicator LED, and this really handy USB out. Why that came in really handy for this project was because all we had to do was power the FPGA dev board directly from USB instead of trying to find a 3.3 and 1.2 volt source. We just let it regulate it itself. We also took the 5 volts to power, or from the power board to power the ESP module, and 5 volts to power the buffers. Let's start on with stuff we've gotten to already. Here's the ESP board on the ESP12, which is itself on the NodeMCU board. It's USB connector, USB to serial connector, and the ESP itself. That connects via SPI over FPGA dev board. The FPGA dev board has this SRAM sitting on, and it's not glued down because it was stable enough to just flap in the breeze like that. It's connected using a cannibalized IDE connector that's soldered to some female headers. And then they're both powered from 3.3 volts. The other thing popping off here is a reset switch. Oh, and the reason we could do the the connection so easily there is because the lineup of the pins is all determined when you do your hardware design and set your signals to each I/O pin. Finally, we have our 48 data lines coming out, which go to our 6 74HC245 buffers. Those in turn pop out the edge of the board to these handy little 25-pin D-sub connectors, 24 signals each and 1 ground. Made it really easy to just buy some cheap straight-through 25-pin cables and connect them up to the screens. I'm not going to go into any detail about the signals inside of here in this video. I'll do that in the next video. For now, let's go check out some of the wiring that we did on the screens themselves and explain how that was set up. So here's a simple drawing of the screens. I didn't have anything to show you directly, but it's probably easier to see on here anyways. We had all the data lines coming from, I believe this was a female D-sub connector, and then we had a male D-sub connector on this side. So we just had the data going in this way and the data coming out the other side so we could daisy chain the screens together. We were using just the regular ws2812b's in these strips with the 5-volt in, data out, and ground. As far as the power goes, we split the panels into 24 rows, top and bottom, and then had power and ground for each of those sub-panels. When we connected them, we started at the top and went to every third to go directly to the rail, and we just daisy chained the power from the first to the second, from the second to the third. I also had a ground going from the D-sub connector itself to the ground rail so that we had a little bit better grounding. We still experienced noise on the data lines themselves. So what we did was added on just a couple lines, not every one of them, just like every 5th or 6th one, we added a small capacitor, which seems a little counterintuitive, but really we're just building a low pass filter here. And this maxes out at about 1 megahertz, so anything that's going to filter out anything above 3 megahertz, 4 megahertz should be just fine. So we used a 1 nanofarad cap here, and you'll see that as 102 on most ceramic caps. Now there's one thing we didn't try which probably would have helped out on the next screen where we got some data errors. What you want to do, what's recommended is, and it could be here or both, is having a small value cap or resistor in line with it in series, something along the lines of, I don't know, 500 ohms. But with that said, we did have a lot of success with the capacitors, and that probably would have just helped. We just didn't try it. The truth is we were doing a lot of this kind of troubleshooting at the very end and didn't have a lot of time, and the fact is we chose these caps just at random and they seemed to work very well. We actually soldered the caps right at the connectors as well, just to give you a heads up. It's a real easy thing to do. It didn't really show up on the screen anywhere, so it wasn't real obvious either. Now I'm going to go over a little bit of the construction itself. I don't have any of the real pictures, like I said, so please bear with me on my drawings. At this point, it might be quite obvious that I'm no great artist. What we did for these screens to construct them is took the strips of WS2812s and hot glued them to a piece of clear acrylic or plexiglass. The plexiglass sheets were 4 foot long by 2 foot tall, and those were mounted to a 4 foot long piece of extruded aluminum that was just basically L-shaped, like angle iron. We attached it by riveting straight to it, pre-drilled it and riveted. And then on the sides, we drilled a hole and put a shim in for a piece of thread rod to go through. And then we put a spring on that thread rod so that it'd create some tension, and just put a nut on the other end. The thread rod fed through 1.5 inch ABS straight through it, and on one end we just bolted it off. In the center pieces we just ran it straight through, and one piece of thread rod held 2 screens. This is pretty much the layout that we had. We had the ABS, then the bolts going through, 2 screens mounted, another piece of ABS bolted through, and another screen. And I'll show you that in some real pictures at the very end. But that's it as far as the construction. It was super easy. One word of caution: if you do this, though, you basically create very large wind sails, which will blow around a bit if there's any light breeze. And these pieces of acrylic are pretty fragile. They're pretty brittle. We in fact had 2 pieces crack on us while after we had put it together, so we had to tape them up. They held together just fine, but it's just a word of caution. It took a long time to get through that video and even a wardrobe change, but those are really just the high level details. Next I'm going to go into the lower level details of the design in the FPGA and the code that I wrote, so stick around for the next video for that. On a lighter note, Murphy's Law will get you every time, and as we were moving the project up, before we even got to show it out, right before we showed out, I dropped the little tablet and it just shatters. And the digitizer broke, so I couldn't control it anymore. Luckily I had the laptop with me as well, so we just used that, but perfect timing. Stick around for just another minute and I'll show you a couple pictures and videos of the finished product. If you liked the video, please give it a thumbs up and feel free to leave me a comment or ask me questions or suggestions or anything. I'll see you in the next one.